about the types of fluid flow. Types of fluid flow. In that, first of all, steady flow will be there. We'll discuss as steady flow and then non-steady flow. In that steady flow, again we'll have the laminar flow and then turbulent flow. Even then we have the compressible flow and then incompressible flow, rotational and then irrotational flow. And by the names only, everything we can get to know easily only, but we'll discuss very fast. So types of fluid flow. In that, first of all, steady flow. What do we mean by steady flow? What happens? Velocity? Velocity is constant at only one point, not throughout the pipe. Actually, whenever I have taken this as a pipe, in that fluid is flowing. The cross-section area might be different. So here, in that fluid is flowing, at that time what happens means, for example, if I consider at any point, at this point, let me take point A and then point B and then point C like this. Steady flow means the velocity is not same at all points. What is same means the velocity is same for the particles whichever is crossing point A. So VA, and then here the velocity will be VB and then velocity is VC. For example, here whenever the first fluid particle is coming, at that time what is the velocity of that particle? VA. Once it crosses, then velocity changes. Again next particle is coming at point A. Again its velocity also how much? VA only. You understand or not? For example, you are entering from that room to this room. At the door, everybody's velocity is same only. Again, whenever you are coming inside, at that time your velocity will be different. Velocity will changes. I am not saying that it will not changes. But at any particular point, the velocity will be constant. So, at this point, always velocity is VA only. Whoever might come, whoever might go, always the velocity at this point is A only. Again, for example, I have taken the fluid particle P. Particle P is crossing point A. At that time, its velocity is VA. Then, whenever that particle P only coming to point B, at that time same velocity or different velocity? Different velocity. Different velocity. Again that will be VB. Whenever it is coming to point C, at that time VC. Three are different. Here I am saying that VA is not equals to VB, that is also not equals to VC. But whoever are crossing point A, they will have the same velocity. Understand or not? So for example, if I make an entry, in that only one person can enter at a time. So up to there with whatever the velocity you come, but exactly at that hole you have to cross with a certain velocity only. Next person will cross with the same velocity. Next person will cross with the same velocity. Once you cross that door, then what happens? Your velocity will changes. You are understanding what is steady flow means? Steady flow means at any particular point, all the fluid particles will have the same velocity. At again, if I take another point, it will be different. So here VA is not equals to VB, is not equals to VC, but for all the particles whoever are crossing point A, they will have the same velocity. For all the particles whoever are crossing point B, they will have the same velocity even. For all the particles whoever are crossing point C also will have the same velocity. Kitne baje hum class? I don't know. By mistake I think I came at 8:30 only. At what time class is? At 8:30 class is. Okay, at any cost you have to enter into the class at 8:30. Clear? Sit. If you come in last, you cannot sit anywhere here. adjust. ಯಾರನ್ನ ತೆಳ್ಳಗಿದ್ದಾರೆ ಅಂದರೆ ಸ್ವಲ್ಪ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೊರಮ್ಮ ಅವ್ರಿಗೆ. So here at any point all the fluid particles will have the same velocity. At another different point they will have the different velocity. That is about the steady flow. Non-steady nothing but what I can say. At one point all the particles will have the different velocities. That's it. So the main thing is here at all the points they are having different velocities, but at one point all the particles are having the same velocity. You are understanding the difference, right? That is about the steady flow and then non-steady flow. If not same, then non-steady flow obviously. Then in that only next one we can say it as laminar flow. What do you mean by laminar flow? Laminar flow nothing but all the fluids will flow with the streams. all the streams should be parallel to each other. This is not the laminar flow. Why? Because they are having this different of paths. If I say the laminar, nothing but, for example, if I have this as a pipe, at that time in that all the fluid particles should flow with the parallel streams. These are the parallel streams. Then this flow is known as the laminar flow. Next one is turbulent flow. Turbulent flow nothing but zigzag manner. The fluid layers will flow with the zigzag manner. That flow is known as a turbulent flow. And next one is compressible flow. What do you mean by compressible flow? Whenever you are compressing something, then what happens? Density will changes. Whenever you are compressing a gas, at that time what happens? Density will increases. So whenever the density of the fluid is changing, at that time we can say it as compressible. If it is not changing, we can say it as a incompressible. That's it. Anything is compressible, nothing but, for example, I am compressing some spring. At that time what happens? Density between the spring layers will decreases, obviously. Density will density will increases. Whenever you are compressing a gas, at that time volume decreases and then density will increases. So density is changing means that is compressible. Density is not changing means that will be incompressible flow. That is about the compressible and then incompressible. Rotational and then irrotational. What do you mean by rotational and then irrotational? Rotational and then irrotational. Whenever you are just opening a tap into the bucket of water, already water is there in the bucket, into that we are just opening the tap. At that time what happens? How it will fall? It will fall in the bucket, and then what it will form inside of the bucket? It will form the circles. You are able to remember that? Yes, you are identifying that. So whenever it is just falling into the, already water is there, into that water it is falling nothing but at that time what happens? It will form the circle. Whenever the fluid particles are rotating by their own axis, at that time those type of fluids flows are known as a rotational. If they are not rotating, that is a irrotational. So whenever you see any dam opening is there, at that time how the water will go in and then it will fall like that. Correct? Why? Because those are rotational fluids. So that is about the rotational and then irrotational. Rotational means the fluid particles will rotate by their own axis. If not, that is a irrotational. So one is the steady flow and then non-steady flow. Steady flow means what? All the fluid particles will have same velocity at the same point. At any point they will have the same velocity. At different points they will have the different velocities. Here VA is not equals to VB, is not equals to VC. But whoever are coming to point A, all will have the same velocity, that is how much? VA only. Whoever are coming to point B, they will have the same velocity, that is VB only. That is about the steady flow. If they are not having the same velocity, at that time what we can say, that is a non-steady flow. And also laminar flow. Laminar flow nothing but all the streams of water will be parallel to each other. They should be parallel, they should be displaced equally. That is about the laminar. Whenever you say the turbulent nothing but they will be in the zigzag manner. That is about the turbulent flow. Next one is compressible. Compressible nothing but density will increases. Whenever you are compressing, at that time density is changing something. That might be increasing or decreasing. At that time that flow is known as the compressible. If the density is not changing, that is a incompressible. Rotational means the fluid particles will rotate by their own axis. If they are not rotating, that is a non-rotational flow, otherwise irrotational flow. That is about the types of fluid flow. Right, that steady and then non-steady. Types of fluid flow. Types of fluid flow. Steady and non-steady flow. All the fluid particles crossing any point of the pipe, will have same velocity, then flow is known as steady flow. In the next line, if the particles are having different velocities, at one point is known as non-steady flow. Draw this diagram only for the steady flow. The diagram is for only steady flow. ದರ್ಶನ್ ಅದು ಸ್ವಲ್ಪ ಅರೇಂಜ್ ಮಾಡು ಬೆಂಚ್ ಅವ್ರಿಗೆ. Finished? Next one is laminar and turbulent flow. Laminar and turbulent flow. For the laminar flow, all the fluid streams are parallel to each other and they should displaced equally. In the next line, fluid streams are in zigzag manner. Next one is compressible, incompressible. For the compressible, density varies For the incompressible, density does not vary. Next one is rotational, irrotational. For rotational, all the fluid particles will rotate by their own axis and forms eddies. What do you mean by eddies? Circles. The circles inside of the water is known as the water eddies. For example, if you see in the electromagnetic induction, you will get the eddy current. What do you mean by eddy current? Whenever you are taking one metal pendulum will be there, for example metal fork like thing will be there, that fork you are just making to oscillate in between the two magnets, north and then south pole. At that time what happens? Nothing but inside of that fork eddy currents will be formed, nothing but currents will form in the circular shape. For example, in between I have two magnetic poles here, one is north, another is south. In between them I am having some simple pendulum. For that pendulum, down what you are hanging, nothing but you are just hanging the metallic plate, not the bob, you are hanging the metallic plate. That metallic plate will be there exactly like this. This is a metal, in between gap, and then in this metal again, gap and then metal again. Whenever you are just making it to oscillate in between the north and south poles, at that time in that metals what will be formed? Nothing but eddy currents will be formed like this. Whenever it is oscillating, whenever it is entering in and then coming out, at that time what happens? Nothing but the number of magnetic field lines will changes. The flux changes will forms what? Potential it will form. Whenever the flux is changing, at that time what happens? Potential will be formed. By that potential, eddy currents will be formed. Eddy is nothing but just in the circular shape. Water eddy is nothing but water is rotating in the circular shape. Eddy currents nothing but current is rotating in the circular shape. That's it. Eddy is nothing but anything that is forming in the circular shape is known as a eddy. Okay. So what I said about the rotational flow? They will rotate by their own axis by forming the eddies. Then next one is irrotational, by forming the eddies. Next one is irrotational. Fluid particles cannot rotate in uniform circles. Fluid particles cannot rotate in uniform circles. Uniform circles. That is about all the types of the fluids flow. One is the study, nothing but at one point the velocity should be same. At another point again all should have the same velocity. Again at another point they will have the same velocity only. So that if we compare the entire velocities, they might be different, but at one point they should have only one velocity. At point A, one particle is moving with 5 meter per second, nothing but next particle also will move with the same velocity only. That is about the study. If we are taking the flow is non-steady, nothing but at that time what happens? The velocities will be different obviously. And also laminar, nothing but what I said, all the streams should be parallel to each other, exactly they should be equally displaced. That is about the laminar. And then turbulent flow, nothing but what I said, they should be in the zigzag manner. Compressible means density changes, incompressible nothing but density does not changes. Rotational means they will rotate by their own axis in the uniform circles by forming what? Eddies. In the irrotational nothing but they will rotate however but not in the uniform circles. That is about the irrotational flow. And then next one is equation of continuity. Equation of continuity. Equation of continuity. Equation of continuity. So here I have taken a pipe with different areas. Let me take this area is A1 and then this area here is A2. Now tell me first of all, whenever you might be watering the plants, at that time what happens whenever you squeeze the pipe? At that time what happens? The water will come with a more velocity or less velocity? More velocity. Whenever you just open it normally, at that time what happens? It will flow with the less velocity. Less velocity and then more velocity. You just remember that points. And also I am asking you here, in 1 minute of time the fluid will flow with the same quantity, otherwise different quantity. Whenever you squeeze the pipe, at that time what happens? Water will come very less, right? Very smaller area of water will come. So at that time, for example in 1 minute I have flown 10 liters of water whenever the pipe is open normally. Whenever I squeeze it, at that time in 1 minute I can flow 10 liters of water, otherwise less than that. 10 liters of water only. Why? Because here the velocity was less. Now the velocity is more. Understanding or not? In 1 minute, for example, if I say at this opening in 1 minute 10 liters of water is coming out. At this opening what happening? Area is very less. But whenever the area is less, at that time what happens? Velocity will be more. Here velocity is less. Here area is more and then velocity is less. Here area is less and then velocity more. Balanced or not balanced? See that here less area, here more area. Balanced. Here more velocity and then less velocity. So everything is balanced here. Nothing but the quantity of water flowing per second is always equal irrespective of the areas. You have to take that whenever you are taking a quantity of the fluid. Let me take 1 liter of the water is flowing for 1 second, nothing but whatever the area might be, how much ever it might be big, how much ever it might be small, the fluid how much it will flow out, nothing but again how much, 1 liter only. In 1 second 1 liter of the water is entering, 1 liter of the water is flowing out. How it is changing, nothing but how it is happening, nothing but whenever the pipe is open, at that time open with a very big area, at that time what happens, nothing but the fluid will flow with the less velocity, the speed of the fluid will be less. Whenever you are squeezing it, at that time what happening, nothing but the fluid flow speed is more. Speed is more, nothing but more number of people will come out or less number? More number of people. If you are taking very big area, at that time they are moving slowly also, the same thing only. In the smaller area they are moving fast also, the same thing only. So here equation of continuity will states that the amount of water that is dm by dt. What do you mean by dm by dt? Rate of flow of water. Here mass we are taking here. The rate of flow of water is always constant, irrespective of the area, irrespective of the speed, everything always it will be constant only. dm by dt, nothing but in 1 minute if I flow 1 kg of water at this area, even in 1 minute at this area also you will flow how much of water? Only 1 kg of water. We should not think that here smaller area nothing but less water will flow, here bigger area means more water will flow. Obviously less water only flow with the more speed. Here more water flow with the less speed. Again the same thing is only happening here. Here area is decreasing and then velocity is increasing. Here area is increasing and then velocity is decreasing. However, it is balanced only. So that always equation of continuity states that the flow of water per second is always constant only. The rate of flow of water is always constant throughout any pipe which is having any cross sectional area. So the pipe might be like this also. The pipe might be like this also. Anyhow it might be. At each and every cross sectional area per 1 second how much fluid will flow, nothing but same amount of fluid only. So always you have to remember that the rate of flow of water will be always constant. So that is dm by dt. Here dm by dt nothing but what happens, what will come? What is the mass, nothing but in terms of, I want to get in terms of density, right, obviously. So that rho is equals to, what is the formula you will get? Mass by volume, and then mass is equals to density into volume. So that d by dt of rho into v is equals to constant. So d by dt of rho into v is constant, nothing but rho is density is constant, however it is incompressible flow only. And then in the place of volume what I can write? Area of the pipe into the length of the pipe, how much it is flowing only. So that what I can say, rho into d into al by dt is equals to constant. So again area of the pipe is at one cross section it will be constant. At this cross section area is a1 only, at this cross section area is a2 only. Now whenever I take even a also out, then what is remaining here? dl by dt. What do you mean by dl by dt? The rate of change of displacement only, right? Length of the pipe nothing but displacement only. So that what I can say, this is the velocity, then rho av is constant. And then here water is flowing nothing but here coming out also water only. So the density also constant only. But the area is changing here. Here area is a1, velocity is how much here? v1. Here the area is a2 and then velocity is how much? v2. So from this what I can write, a1 v1 is equals to a2 v2. Very very important formula we are going to use in number of problems. Even in the torricelli list, every derivation also you are going to use this one. Okay. So equation of continuity nothing but always the amount of fluid flowing per second is always constant. You are able to see that backside people? Shall I derivate on the up otherwise? Yes, I will do that. So always equation of continuity states that the amount of fluid flowing per second is always constant only, whatever the amount may be. So that dm by dt is always constant. Here dm by dt nothing but the amount of fluid flowing per second. So that amount I don't measure in the water in terms of mass and all. So what I will take nothing but dm by dt here dm by dt is constant, so that d by dt of, in the place of mass what I can write, density into volume, that is equals to constant. However, density is constant only throughout the liquid, only one fluid only, no, we are flowing here. So that density is constant, then d by dt of area into length is equals to constant, then d by dt of area will come out, and then dl by dt is equals to constant. What do you mean by dl by dt? Velocity, so that AV is constant always. However, density will go here. Fluid is same fluid only. Here we are flowing, water means water only. Here also oil means oil only. So the density is same, but the area is varying here. So only I am keeping area as it is. As the area varies, then what will varies? Velocity will varies. So that what I can say, A1 V1 is equals to A2 V2. This is the equation of continuity, and this is also even we can say as the rate of fluid flowing per second, otherwise volume. The fluid volume also is constant only. Here area into velocity, velocity is coming as what? dl by dt. Area into length is what again? Volume of the water only. So volume is amount of fluid, nothing but what? Volume only, right? The volume will be constant. Rate of flow, otherwise volume we can say. So everything is constant only. The equation of continuity states that the amount of fluid flow will be always constant throughout the pipe, any pipe it might be. Clear? That might be having any different areas. For example, if I say here the area is A1, here it is A2, and then here it is A3, then A4. Then what I can say? Equation of continuity. A1 V1 is equals to A2 V2 is equals to A3 V3 is equals to A4 V4. That is how we can find out the velocity at any area. Clear, right? Whenever the area is bigger, at that time what happens? Velocity will be lesser. Area is smaller, nothing but the velocity will be more. Clear? Right, that equation of continuity. Equation of continuity states that equation of continuity states that when a fluid is flowing, through a pipe of non-uniform cross sections, through a pipe of non-uniform cross sections, through a pipe of non-uniform cross sections, the amount of fluid flowing per second is always constant. In the next line, rate of fluid flow is always constant. Rate of fluid flow is always constant. In the next line you write, the fluid velocity will be less, at the larger cross section, and it will be more at the smaller cross section. Note down everything. Pipes should have different cross section areas. Next one is Bernoulli's theorem. Bernoulli's theorem. In dynamics, almost all the problems are based on Bernoulli's theorem only. Bernoulli's theorem and then equation of continuity. Even this Bernoulli's theorem also based on the equation of continuity only. So you have to understand this properly. So here, for example, I have taken a non-uniform cross-section area of the pipe. So here area is A1 and then here area is A2. Let us consider the area is A1 here and then here A2. So pressure at this point is P1 and at this point is P2. Now we are not even talking about the points here. First of all, let me take, you just assume the paste, toothpaste. Whenever I just say this one as a fluid flow, at that time just assume the paste. Here what happening, nothing but, for example, my fluid is flowing from, let me take the points R to R dash, R to Q, I am sorry, R to Q. In one point of time what happening, nothing but fluid flow is there between the R to Q. So at the time lapses, then what happens? What happens? It will displaces, right? Obviously it is displacing from, let me take R to R dash here, and then now fluid flow is there from here to here. Let me take that is Q dash. Initially between which point? R to Q, from here to here. Now it is displaced from here to here. You understand? In how much time? Nothing but in the time of delta t. In the time of delta t, what happening, nothing but, you just don't consider that here again the water is coming, right? That and all you don't assume. Just we are taking at one point of time what happening in the pipe only, not outside. Whenever the water is entering into the pipe, at that time the fluid flow is there in between what here, R and then Q. From here to here it is there. Next, whenever after time t, if I say after the delta t time, very small time, then what happening, nothing but fluid is there in between R to R dash to how much it is, Q dash. Initially between R and Q, now what happening, it is just exactly displacing like this. Then that is from where to where, again R dash to Q dash here. Then this is entirely based on the conservation of energy only. So what is the conservation of energy? Always the energy will be constant, energy will not changes anywhere, anyhow. And also based on the work energy theorem also. What is the work energy theorem here? Work done is equals to change in kinetic energy. If only kinetic energy is there, nothing but work done is equals to change in kinetic energy. If potential energy also there, means then work done is equals to change in potential energy also. The fluid is there some height also, H1 and then H2, two are different heights here. So it will have even potential energy. It will have even kinetic energy. Why? Because the fluid is flowing with velocities V1 and then V2, let us consider. So at that time it will have the kinetic energy and then potential energy. Then work energy theorem is the total work done is equals to change in kinetic energy as well as change in potential energy also. In the mechanics, whatever we got one time the conservative forces, at that time we got work done is equals to change in potential energy, that is W is equals to delta U we got. Even in the normal work energy theorem also, work done is equals to what I said, change in the kinetic energy. If two are there, at that time what I can say, change in kinetic energy as well as potential energy. That is about the work energy theorem. First of all, you have to find out the work done here, work done at this portion R to R dash, and then work done at this portion Q to Q dash. Now fluid is flowing nothing but it is applying some force or not? Fluid is flowing with some force obviously. So what is the work done formula for us? Work done is equals to force into displacement. Now here fluid is flowing with a velocity V1 and making how much time here in the how much time, delta t time, and then flowing with a velocity V2 in how much time, delta t time again. So here what I am saying nothing but, first of all, work done will find out at point that the end A, at A we'll find out the work done. Work done is equals to, what is the formula for us? Work done is equals to force into the displacement. How much displacement it is made? R to R dash, at B Q to Q dash. So at A, first of all, it is moving from R to R dash here. That is the displacement we made. So displacement is equals to, velocity is equals to displacement by time. Then displacement is equals to what I can write? Velocity into time I can write. Now here force, how much force it is applying? Force is equals to what will you get here? Pressure is there. Pressure is there and then area is there here. So pressure is equals to, what is the formula for us? Force by area. Force is equals to pressure into area. So at end A, what is the area we are having? A1. Pressure is how much? P1. So that force by the fluid is how much? Nothing but P1 A1. How much displacement it is traveling? R to R dash. R to R dash, it is moving with what velocity? V1 velocity. In how much time it is moving? Delta t time. So that V1 into delta t. This is the work done at the end A. Right. Then work done at B we will find out. At B, again work done is equals to force into displacement only. Here fluid is coming in and then it is coming out. At that time what I can say? Nothing but it is a negative we can take. The work done, actually here the work done by the system we will get. Here the fluid is entering inside, nothing but we are doing the work on the pipe. And it is coming out, nothing but who is flowing it out? Pipe only, right? That is the system. Work done by the system we will get in negative. That topic you will get in the thermodynamics. But as per now, from here it is gaining the fluid, from here it is losing the fluid. So only what I can say, nothing but the WB is equals to what I can write here? Force into displacement, right? Force is nothing but here what is the force applied? P2 is the pressure and then A2 is the area. Velocity is how much? V2 into time is how much here? Delta t. It is losing, right? So only here I am taking it as minus. Clear? So this is the WA and then WB, the work done at A and then work done at B. So now tell me, from the equation of continuity, can you apply the equation of continuity here? Yes, we can apply. What is the equation of continuity states? A1 V1 is equals to A2 V2. Just remember that. Now I want to find out the total work done. Total work done WT is equals to what I can write? WA plus WB. The total work done is WA plus WB only. So what is the WA here? P1 A1 V1 into delta T plus P2 minus or plus or minus P2 A2 V2 into delta T. See here A1 V1 is equals to A2 V2. Can I say that this is equals to change in the velocity, change in the volume? Volume is equals to what is the formula for us? Area into length. Per unit time, nothing but what you can get? Volume is equals to area into length, right? Area into length. Length nothing but what I can say? Velocity into time only again. So velocity into time. This entirely A1 V1 delta T, A2 V2 delta T is equals to, can I say that is a change in the volume? Yes, you are understanding that. That is a very important thing here. Actually the volume is nothing but area into length. So what I am doing, nothing but here A1 V1 nothing but what is the equation of continuity states? The amount of fluid flowing per second. Nothing but what you have to take here? V by T is equals to area into velocity. That is the equation of continuity, right? That is equals to always what? Constant only. The amount of water nothing but dm by dt. Otherwise volume per second. That is a flux we call it as. Flux of the fluid flow. Flux nothing but what? Generally flux nothing but what in electrostatics? Number of electric lines, otherwise number of magnetic field lines. Here also the amount of fluid flowing per second is also known as the flux. So here fluid flux we call it as. So here V by T is equals to, otherwise dm by dt is equals to what is that? A into V only, that is equals to always constant. So here whenever I send T that side, then V is equals to what I can say? AV into T. So here also what we are having here? A1 V1 delta T, A2 V2 into delta T. As the time is changing, at that time what happens? Nothing but volume also changing only. So clearly what I can write here? P1 minus P2 into what I can take out here? Delta V. That is the work done total. The total work done is equals to here A1 V1 delta T and then A2 V2 delta T. A into V into delta T is known as the volume for us. So already we have seen in the equation of this one only, no, we got it here already. So here d by dt of A into L nothing but what? Volume only, right? From here, from this equation, d by dt of AL nothing but what? Volume is equals to constant. So dV by dt, in the place of constant what I can write? Area into velocity only. Then here only volume is equals to what I can say? dV is equals to what I can say? AV into dt. Otherwise delta V is equals to what I can write? AV into delta T. That is what we are getting here. You understand now clearly? Yes, from the equation of continuity, d by dt of area into length is nothing but d by dt of volume only. Is constant nothing but that is again what? Area into velocity only. So that is dV by dt is equals to area into velocity. Here dV nothing but what I can write? AV into dt. If I apply the delta, delta V is equals to what I can write? AV into delta T. Here also A1 V1 delta T is there. Here A2 V2 delta T is there. From that what I can say, from the equation of continuity, they are having the same volume only. So that is delta V I can take common, that is P1 minus P2 into delta T. That is the total work done. Now you have to get the kinetic energy as well as the potential energy. That will be easy only. So kinetic energy you have to get. The total kinetic energy you have to get, change in the kinetic energy. For that, again here volume is changing nothing but can I say mass also changing? Density is constant. However, density is constant, but volume is changing nothing but who is changing indirectly? Mass is only changing. Density is equals to mass by volume. I said that density is constant, volume is changing. Then indirectly in the numerator mass also changing only here. Now kinetic energy is equals to, kinetic energy at A and B is equals to what I can write? Delta KE is equals to, delta KE is equals to what I can write? Kinetic energy at point B minus kinetic energy at point A. Rate of fluid flow is always constant by the equation of continuity. So what is the kinetic energy at point B? Half into mass nothing but how much mass here? Delta M. Volume is changing nothing but indirectly who is changing here? Mass is changing. Delta M into velocity at B is what here? V2 square minus half delta M into V1 square. Why delta M only? Change in the mass is same. Delta M in how much time we are taking here? Delta T. Here also how much time? Delta T only. From the equation of continuity, here the area is less means in delta T time the mass is there with more velocity. So again change the mass is same only. Here mass is flowing with a less velocity. So again same mass only. So that here what I can take common nothing but half into delta M I can take common V2 square minus V1 square. That is a change in kinetic energy. What is the change in potential energy? Change in potential energy. This area is there at what height? H2 height, and this area is there at what height? H1 height. So that work done by the gravity, otherwise change in the potential energy. What I can say? mgh2, delta mgh2 minus delta mgh1. So delta mg is common. I can write h2 minus h1. This is the change in potential energy. Now our total work done is equals to, from the work energy theorem, what I can write? Change in kinetic energy plus change in the potential energy. So from the work energy theorem, the total work done is equals to delta KE plus delta PE. So total work done, what is the formula we got? Total work done is equals to what we got? P1 minus P2 into delta V we got. So that is P1 minus P2 into delta V is equals to, change in kinetic energy is how much we got? Half delta M into V2 square minus V1 square plus potential energy is how much? Delta M G into H2 minus H1. Now what is this states nothing but, for example, you are just dividing with delta V both the sides. Whenever you are dividing with delta V, here pressure into volume, that is nothing but water. Energy again, work done only. Work done is equal, can I say energy only? Work done nothing but energy only, right? Change in the energy only gives you the work done. So here also energy only, this is also energy, this is also energy only. What I can say nothing but the total change in the kinetic energy plus potential energy is equals to change in the pressure energy. That is what the work, this one, conservation of energy. So initially, how much pressure energy we are having? Nothing but P1 minus P2 into delta V. Kinetic energy, how much we are having? Nothing but half into delta M into V2 square minus V1 square. Plus potential energy is delta M into G into H2 minus H1 we are having. Now, in both the sides, I am just dividing with delta V. Whenever I divide with delta V, what I can say? Can I say that pressure energy per volume? And whenever I am dividing this one, kinetic energy per volume, and then here potential energy per volume. You understanding, right? So that is delta V. Whenever you cancel both the sides at that time, what we are remaining with? P1 minus P2 is equals to half into delta M by delta V is what? Density, right? Mass by volume is equals to density only. Constant density we are having. So that half rho into V2 square minus V1 square. Again delta M by delta V nothing but again rho G into H2 minus H1. This is what the Bernoulli's principle states. Now here I can take all the first terms one side and all the second terms another side. So here P1 is there already. From here I will get half rho V1 square in this side. Again what I can get here? Rho G into H1 I can get. All the second terms one side. P2 is going that side, so that P2 plus again what is there here? Half rho V2 square. Again what is there? Rho G H2. So initial is equals to final. Then what I can say? Sum of this quantity is equals to what I can say? Constant. So that pressure P plus half rho V1 square plus rho GH is equals to constant. Initial is equals to final means what I can say? Everything is constant only here. So this P is known as the pressure energy per unit volume. This half rho V1 square is known as the kinetic energy per unit volume. This rho GH is known as the potential energy per unit volume. Clear? Then everything is equals to what I said? Constant only. So, and also whenever you are just dividing with density, dividing everything with density, at that time what will you get the equation as? P by rho. Here what will you get? Half V1 square, then GH is equals to constant. This one is known as the pressure head. This is known as the kinetic energy head, and then this is known as the potential energy head. Nothing but on the head of the density, pressure is there, and then kinetic energy is there, potential energy is there. That is about the pressure head, kinetic energy head, and then potential energy head. Sakaitu? Copy ಮಾಡ್ರಿ first. Explain ಮಾಡ್ತೀನಿ ಮತ್ತೆ. ಅದು ಪಾಸ್ ಮಾಡಮ್ಮ.